All right, hello and welcome back to another lecture video. Today we're going to go over functions, which is one of the topics that comes up in worksheet number 2. So the section that I'm going to cover in this video is section 2.4, and we're just going to go over a brief review or a quick review over functions. It's covered in problems number 1, problem number 4, and problem number 5. And so let's go ahead and take a look at the material here. And this material is from the textbook that we're using for this class. You can access that through Alex. I have it open here. So we start with the definition of a function. A function is a relation where each element of the domain corresponds to exactly one element of the range. Okay, so functions, we're going to get into the way we normally see them, but it's just a set of points, basically, where each element in the domain corresponds to exactly one element of the range. And so what that means is, well, let's take a look at something that is not a function. And let's start here with number 17. If you take a look at picture, for problem number 17, we can see that we have the coordinates -2, 3, and these are x, y coordinates, ordered pairs. And then we also have -2, -4. Now we can see this point right here and this point right here. And so you see that there is an element of the domain, -2, right there. It corresponds to not exactly one element of the range, but two different elements in the range, 3 and 4. And so this would be, this would not be a function. Okay. Since there's an x value that is paired with multiple y's. Okay. Now, well, a function is a relation, a set of points, where each element of the domain corresponds to exactly one element in the range. So let's take a look at example 16, -4, -2, 0, -2, 5, -3, 1, 3, 3, 4, and then our last point is -3, -3, 5. So we would ask ourselves, is this a function? Is every x value that shows up here paired with exactly one element in the range? And the answer is yes. None of these x values is paired with more than one element of the range. Like 0 is only paired with -2. 5 is only paired with -3. Yeah. Now, sometimes students get confused because they say, well, what about that -2? But that's not an element in the domain, right? So elements in the range might be paired with multiple elements in the domain. But as long as an x value doesn't repeat, then we're okay. All right, so you can try problem number 11. Pause the video and determine whether or not it's a function. Number 16, though, is a function. So we'll say, yes, it is a function. Okay. All right. Number 11, hopefully you paused the video and tried it. We can take a close look. This would not be a function because here we have an element in the domain, 4, that is paired with multiple elements in the range, -5. So this is not a function. Okay, so how can we tell, without actually writing out the points, just by looking at the graph, how can we tell whether or not something is a function? There's something called the vertical line test. And we can use the vertical line test to tell whether a graph is a function. And it's a very quick check if you have a graph. And the way that we do it is we take a vertical line, just like this one here, and we run it across the graph. And if this vertical line ever touches 2 points on that function, it is not a function. Oh, sorry. If we run it across the graph, and if it ever touches 2 points on that graph, like here, then this means it's not a function. So you can very quickly check whether or not something is a function. Here, it fails to be a function. Let's go to problem number 16 and see, okay, only 1 point is being touched there. Only 1 point is being touched there. 1 point, 1 point, 1 point, 1 point. Never would a vertical line touch 2 points on problem number 16. So this is a function. Let's read what the vertical line test says. Given a graph, a given graph is the graph of a function if and only if every vertical line intersects the graph in at most 1 point. Okay, so the wording is always a little bit funny for students. But if every vertical line touches at most once, then it is a function. Here, that is the case. So this is a function. That's what we said. And then here, no, not every vertical line does not intersect at most once. Here, a vertical line intersects more than once. So this is not a function. Okay, so the vertical line test is a very good test for checking whether or not something is a function. Okay, well, here we have a bunch of examples. And so we'll do a few of them. Maybe we'll do all of these here and determine whether or not they are functions. So let's start with the number 35 and just quickly, determine whether or not it's a function. And then it also says determine the domain and range of each. If it is not a function, the set of points is still called a relation. So the instructions say determine whether or not the relations indicated represent a function, then determine the domain and range of each. So let's see, I'm going to use the vertical line test, and nowhere does the vertical line cross more than once. So this is a function. So I will write here for number 35, function. And then the domain, I'm just going to write D for domain since I'm doing a bunch of problems here. The domain, it looks like, I'm going to zoom in here. The domain we can determine by looking at where the vertical line starts to cross the graph. Here at -4, I'm now touching the graph, and I'm still touching the graph all the way up to a value of x equals 5. So from -4 to 5, since we have closed circles on the end of this segment, the domain is -4, 5 with square brackets. The range, you can use a horizontal line for the range. So I'm going to use horizontal line like this. And we want to know what's the lowest point on the graph. The lowest point is here at this, what is this, -2. And then the function continues to rise and go to the left all the way up to this y value, which is, what is that, 3? Yeah. So for range, I'm looking at y values. This goes from -2 all the way up to 3. And the x's we said were from -4 to 5. So the range is going to be from -2 to 3. And you can pause, the video where, I'm showing all of these problems here and, do them yourself. And then, you can just check your answer when we do them together. So I will skip some of these though. These are a lot of problems. So let's take a look at, we'll skip one and we'll do number 36. Oops. Whoa. Okay. So let's first start with the vertical line test. Is this a function? Well, we run a vertical line across the graph and just check. If it crosses more than once, then it's not a function. Here, it never crosses more than once, so this is a function. So we will say function. And then we'll find the domain and range. The domain is the set of all x values where a vertical line would cross it. Notice the vertical line starts crossing here at -4. And since it has this arrow on the end of it, it indicates that it continues to go to the right and down. And so the domain is going to go all the way to infinity. So this is -4 to infinity. The range is, we always want to write them from least to greatest. So how low does the function go? This thing continues to go, it will continue to go down to -infinity because of that arrow. So -infinity is the lower bound on the range, and the upper bound is goes as high as 5. Notice there's a dot there, so it stops at 5. So the range is -infinity to 5 with the bracket. All right. Let's take a look at number 38. Is this a function? No. The vertical line crosses more than once, so this is not a function. So we'll write not a function. What is this? This is still, so we care that it's not a function, but it's still a relation because it's still a set of points. Okay. So what's the domain of this relation and what's the range? We can still find the x values of the points on this graph, right? So over here, the graph does not exist, right? For these x values in the negative, this negative side. But here, the vertical line at x equals 0, now it's crossing the graph. And it continues to cross the graph until we get to this x value of 3. And my domain then will be 0 to 3. Now, there's sometimes a question of whether this 3 should be included or not. And the answer is that it is included. We should use a square bracket. Any point is technically a closed dot unless it's indicated otherwise. If there had been like an open circle here, then we would put a parentheses on that 3. Since there is no open circle, we consider it, all of these points are closed dots. Okay, so 0 to 3. What's the range? The range from bottom to top is, let's see, the function is right there. This vertical line is now crossing here at -4, and it continues to cross until we get to +4. So the range is -4 to +4. Let's see if we can find another interesting one. Don't want to make these videos too long, so let's see here. We'll do maybe just 2 more. Yeah, let's do the circle. Why not? And number 42. Is this a function? We run the vertical line. If it is a function, the vertical line should cross at most 1 time. So this is just a relation. We'll say the relation is not a function. Okay. What's the domain, though? The domain and range can still be given. The domain is how far left, essentially how far left the function goes and how far to the right. It looks like the function starts right here in terms of x values at x equals -3 and continues until we get to x equals 4. So just to mark those, this is -3 and this is +4. We're really just writing this interval right here. So -3 to 4. And then the range will be essentially these values here. Oh, 1 second. Oh, never mind. Okay. That the y values go as low as -3 and as high as +4. Okay, so the range is -3, +4. All right, my son is acting up. I can hear him. All right. Okay, so hopefully that's good with everybody. I usually don't really leave these markings here, so I'll take them off. They're not part of the function. They're just to show, what the domain and range are. Yeah, and one way to actually describe it, I guess I forgot who said this, but it is like if you squish if you were to squish the function towards the let's say the y-axis, it would go where that green is, and if you squish the function, just squeeze it towards the x-axis, that would give you the domain, and that's where that blue is. Okay, so if it helps you to imagine it that way, that's good. Yeah, okay, we'll do one more example since we just gave that little excuse me, that little way of thinking about it. All right, so let's take a look at the last one here, number 44. Is this a function? What do you think? Looks like it crosses at most one time, so this would be a function. So it's still a relation also. Relation is a function. A relation is just a set of points. So if it's a set of points, it's a relation. But this one here is also a function, and that's what we care about. We're interested in functions most of the time in this class. What's the domain? And what's the range? The domain is going to be the set of x values that this function takes on. And you can see it looks like it starts right here, but this arrow indicates that it continues to go to the left. This function will keep going to the left and up. And so the domain is going to be, if I were to squeeze this onto the x-axis, this point here would go right here. And then we can see that it would go like that, go in that direction. And then this ray here would go right here in that direction. And so the domain is going to be from -infinity to +infinity. What's the range? Well, the range, we map this thing onto the y-axis. And then if you can continue to map all of these points onto the y-axis, but it's going to be the set of points like this with arrow. It's got an arrow on top. That means it continues to go up. And so what is that set? -3 to infinity. Okay. All right. Very good. That's, those are the examples that we'll do for domain and range and whether or not something is a function. Something else that comes up that I mentioned on the worksheet is problem number 5, which asks you to determine the implied domain when you're given a function. And we'll do a couple of examples. This is now, oops. Okay, it's somewhere in the textbook. Yeah, here we go. Domain and range. So this is kind of what we were looking at, a vertical line running it across that helps us figure out the domain. And so let's go ahead and move on. What if we're given a function as an equation, right? How can we find the domain, the implied domain of these functions? Well, for a rational function, meaning a function that's a fraction that has a polynomial on top and a polynomial on the bottom, we'll take number 48 for example. The way that we do it is we set the denominator equal to 0 and solve for x. We don't want the denominator to be equal to 0. So we set it equal to 0 to figure out which x values will make the denominator 0, and then we exclude those values from the domain. The domain of a rational function is going to be all real numbers except those that make the denominator 0. Okay, so for problem number 48, we set the denominator equal to 0. We can solve this equation for x. X equals -3. And this is the value that we want to exclude from the set of real numbers. The domain is going to be all real numbers except that one right there, -3. And so the way that we write that, we're not going to write the word except x equals -3. We're going to write it as -infinity to -3 union -3 to infinity. And notice this is, I'll show you the graph just to show it. Here is the domain of that function. It is all numbers except for -3. I have an open circle there at -3. We skip that one. We do not include it as part of the domain. Okay. There's a lot of good examples in this textbook here. You can actually notice, you can take a look at example A here, example 6A, and they have something very similar to what I've just written. So there's a lot of good examples. You can take a look at this book here to get more examples if you'd like. So that's for a rational function. Let's take a look at, I'll write it in green, a square root function. I'll do this one here, number 50. What about for a square root function? We have issues when we try to take the square root of a negative number. If we want real valued functions, in this class we only deal with real values, no imaginary numbers. So for number 50, since it has a square root, we need to make sure that whatever's inside the square root is never negative. If it's not negative, then that means that we must have the inside of the square root be larger than or equal to 0. So this is how we find the domain of a square root function. We just set the inside larger than or equal to 0 and solve for our variable. Okay, so it's actually called the radicand. Whatever's inside of the radical symbol is called the radicand. We set it greater than or equal to 0. I'll put it in a box here. This is the procedure that we're going to take and then solve. Okay. So we add 2 to both sides. 5a equals 2. Divide by 5, divide by 5. A equals, I made a big mistake here. It's not a huge mistake, but the symbol is greater than or equal to, and for some reason I changed it to an equal symbol. You should not do that. So let me fix that. I'll put that top bar and make it a greater than symbol. And so this should be greater than or equal to. 5a is greater than or equal to 2. If I divide by 5 on both sides, then I get a is greater than or equal to 2/5. Okay, and so where are the numbers that are greater than or equal to 2/5? I'll graph this. 2/5 is right here. greater than or equal to, that would be including 2/5 and going in the positive direction. The domain, this is a domain of P of A, so I'll put domain in parentheses P, is this 2/5 to infinity. Okay. And just for fun, let's go ahead and graph this. We're going to take a look at these kinds of functions in the future, later in this class. So the square root of 5a minus 2. Let me pull up Desmos. This is a very good app that you can get on your phone or your tablet or whatever. And I'll put the square root of 5. I'm going to use an x because minus 2. And notice what is the domain? We said from 2/5 to infinity. That should be where the function exists along the x-axis. Hey, take a look at that. Where does it start? At 0.4, it starts. That's 2/5 all the way to infinity. All right, you can see it just continues to go on in that direction. Okay, so that's exactly what we found. If we're trying to graph these functions, it's a good idea to know where the domain is, where the function actually exists, because if we draw anything in the negative, on the negative side over here for this function, that would not be right, because that's not part of the domain of this function. Okay, very good. And I'll do one more example. There's a whole bunch of examples here. Only a couple of them get covered on the worksheet, so I'm not going to spend too much time talking about the other ones. If you're interested in any of those other solutions for these problems, come see me during office hours and we can talk about these. But I did want to show one more because there is a kind of a complicated little one that's like a little more complicated on the worksheet, and that is, and I'll point it out. Let me find it. It is E and D. So let's take a look at one E and F, excuse me, one something like this, because there's a fraction and a square root. And so let's take a look at one of these. And this is actually an example from the textbook, so it's very nice. They do it right here, and you can read the solution. We'll do it together, and you can read the solution also. Okay, so I'm going to take a look at B here, because that's the one that's very similar to the one that we have. That's the one similar to what we have in our worksheet. And so whenever we see a square root, we should start with the square root for finding the domain. Okay, so the square root, remember we said we take the radicand and set it greater than or equal to 0. That's our procedure for finding a domain of a square root function. This is a square root in a denominator, so we're going to have to do a little bit more work. But let's start with just getting the radicand greater than or equal to 0. So we solve. Okay. Should be comfortable with solving. If we're not, we need to visit office hours. X is greater than or equal to -5/4. Oops, over 4. And so notice right now, so far, I've restricted the domain to be the numbers that are larger than or equal to -5/4. -5/4 to infinity. But we also have a denominator. We have a fraction. Since we have a fraction, we know that the denominator cannot be equal to 0. So we need to exclude any value that would make the denominator 0. What number would make the denominator 0? I'm going to set my denominator equal to 0. The square root of 4x plus 5, set it equal to 0. And we'll end up excluding this value here. If I want to solve this equation, I can square both sides. 4x plus 5 equals 0. Then I subtract 5. Okay, we basically already solved this. 4x equals -5. Divide by 4, and x is equal to -5/4. This number here, we need to exclude from the domain. Right now, so far we had -5/4 to infinity, including -5/4. But notice that we just said that -5/4 will make the denominator 0. So we need to exclude that value. And the way that we do that is we just put a parentheses next to the -5/4. This is the domain of that function. Okay, -5/4 to infinity, not including the -5/4. All right, so let's see here. Yeah, notice how they do it in the book here. It's a very nice solution. We must have that 4x plus 5 is greater than or equal to 0. This is to keep the inside of the radical non-negative. So that's what we did. Good. And we need to have that the square root, this denominator, not be equal to 0. Okay, so yeah, we did it in two steps. They actually don't really show all the work, I guess, but that's okay. Yeah, so we did it in two steps there. All right, so let's actually graph this one also. I'm kind of curious. Yeah, maybe we can graph it. Maybe it won't be super clear, but 2x over the square root of 4x plus 5. This is the last thing we'll do here. Okay, so let me hide this really quick just for a moment. Notice that the square root of 4x plus 5, its domain is -1.25 to infinity. So that's -5/4, right? To infinity. All right, cool. And then when we bring in this other function, it's actually going to look like the domain is the same thing. But notice that at x equals -5/4, it starts to get really, really close to this vertical line. And it looks like it touches it, but it actually doesn't. If we zoom in further and further here, we can see that there is distance between the vertical line that has an x value of -5/4 and this graph here. So it gets closer and closer to -5/4, this function does, but it never actually touches it. And so that's why the domain is not including -5/4. It never touches -5/4 all the way to infinity. Okay, so you can see the difference there between those two functions. Pretty cool stuff there. Okay. All right. Yeah, so that's the video on the first topic. I'm going to make the videos depending on the topic here. So we'll go over linear equations and function transformations in a different video. All right. Put a like on the video or leave a comment. I'm curious what people think about the videos. So if you watched it all the way through, leave a little comment or something. Be happy to read those. All right. Until next time.